Hello students, welcome back to my YouTube channel Data Shah. In today's lecture, we'll be talking about the least cost method. It is another method of the transportation problem. In the last lecture, we have discussed the northwest corner method, in which we have started with the extreme left corner. Now, as the name suggests, the least cost method. So here we'll be talking about in the matrix the lowest cost cell. So we'll be starting with that particular cell which will have the least cost, the lowest cost, and then the process how you will be allocating the number of units would remain the same. That you have to identify the minimum from the demand and supply, and then you will be allocating that much units to that particular cell. So let us consider the same examples that we have done in the previous lecture. So we have the same example. So let us consider the lowest cell that we have here. The lowest cost cell is 4. So now this is a balanced transportation problem, so we have already discussed that. Now this is 4. Now 200 and 275. So the minimum of the demand and supply is 200. So I'll just delete this, and this would be minus 200. So 75 is the remaining one. Now obviously that I can't allocate. Now after this, I'll be searching out in the rest of the matrix about the lowest cost cell. Now in the lowest cost cell, I will not be considering this particular column, because here for the destination A, the demand has already met, so I cannot consider the lowest cost in this particular column. Now for the rest of the matrix that we have, the remaining cells, the lowest cost is 5. So out of the minimum of the demand and supply is obviously 75, so I'll be allocating it 75 units here. So for the source, from the source third to the destination B, I can allot 75 units. So deleting this and writing this as 25. So 100 minus 75 is 25. Now as you could see, now the remaining here also, and now I cannot have anything from the source 3 to the destination C, because the supply has already met. So I'll be looking out for the lowest cost cell in the rest of the cells. So in the rest of the cells, I have 8 as the minimum cost cell. So 25 and 150 as the demand and supply respectively. So I'll be taking the minimum of them. So the minimum is 25. So this would be 125, and this becomes 0. Now when I have allocated this again, the minimum that I'll be looking would be the remaining cells and not this particular column. So the remaining, out of the remaining, the minimum is 10. So this is 125 is the minimum. It becomes 0, and the rest that I have is 175. So again, you can cross check that for the last cell, the demand and supply would be equal. So the minimum cost that I'll be getting here would be, the minimum cost would be given by the same process, 25 multiplied by 8, 125 multiplied by 10, 175 multiplied by 11, 200 multiplied by 4, 75 multiplied by 5. So when we'll find out, the answer that we'll be getting is 4550. And m plus n minus 1, you could easily find out that 6 minus 1 is 5. So we have 5 positive allocations, as you could see, figure out. So this implies that's a non-degenerate basic feasible solution. Now when we are calculating using the least cost method and the northwest corner method, you would identify, and you can differentiate that the cost that we got there was somewhat around 5900, and here we are getting the minimum cost as 4550. So obviously this is quite less than that. So whenever we are finding the initial basic feasible solution, we could identify that which method we have to choose, and we can find the solution for that particular problem. Now let's consider the second example. Here also we are having the balanced transportation problem because the demand is equal to supply. So we have three sources X, Y, Z, and we have 5 destinations here A, B, C, D, E. So our M plus N minus 1 would be 5 plus 3, that's 8, minus 1, that's 7. So we have to check out whether we are having a 7 allocations, positive allocations or not. So starting with the lowest here, so I have two lowest, 1 and 1 for the Y source, destination A and destination E. So I can start with any one. So here I'll be starting with this. So that's 3 and 8. So I'll be taking the minimum as 3. It becomes 0 and this is 5. Now as I cannot move further in this particular column, so I'll not be considering the lowest cost cell in this particular column, but in the remaining ones. In the remaining ones, obviously I am having again a 1 here. So minimum of 5 and 6 is 5. So this is 5 and the 6 becomes 1. Again looking for the minimum cost cell, but not in this particular row, but in the remaining ones. So I'll be taking 3 here now, as 3 is the lowest one. So the minimum of 5 and 4 is 4. This becomes 0 and this becomes 1. So now looking for the lowest cost cell in the remaining of the cells that we have. So the leftovers that I have, only 4 cells, as you could see here. These are 9, 4, 8 and 12. So out of these I am having 4 as the minimum cost cell. So this becomes 4 and this is 5. So this becomes 0. And now not in this particular column. So obviously the above has already gone before. And the remaining are 9, 8 and 12. So the minimum is 8. So I'll be allocating 1 here. It becomes 0. It becomes 4. Then again this column goes off. So obviously we have already taken this. Out of 9 and 12, the minimum cost cell that we have is 9. So I'll be getting this here as 3. This becomes 0. 4 minus 3 is 1. So lastly I have only 12 left. So the 12 is 1 and 1. So that's a cross check. So we could see here that do we have 7 allocations? So 1, 2, 3, 4, 5, 6, 7. Yes, we are having positive 7 allocations. So that means we are having a non-degenerate basic feasible solution. So let us find out the minimum cost here, and it is coming out to be 3 1s are 3, 9 3s are 27, 4 4s are 16, 4 3s are 12, 8, 5 and 12. So here we could calculate in the previous one, this was 30, 46, 58, 58 and 12 is 70, 78, and this is plus 5, that's 83. So I am getting 83 rupees as the minimum cost. Whereas when we have taken done with the northwest corner method, there I was getting in 153. So you can cross check in that particular video. So there's a lot of difference between the northwest and the least cost method. So let us consider the next one where we have the unbalanced transportation problem. So here when we took this is coming out to be 700. The summation BJ's was 700 and sorry, this was AI's. And summation BJ's is equal to 790. So how to find out? The process remains the same. You have to add the dummy row here with the 0 cost, and this would be 90. So it becomes 790. So we have to make it a balanced transportation problem, and then only we can move ahead. So we have 4 rows and 4 columns. So 8 minus 1, that's again 7. So there should be 7 allocations. Now the minimum cost that we have here is 0, right? So this 0, we'll be starting with that one only, and we'll be considering this. I'm taking the corner one. So 190, so the minimum is 90 only. You can take this particular 0, this 0, or this 0. So it will be 90 only. So any one that you want, if you want to take this one, we can start with this as well. So this becomes 0, and 90 minus 250 is 160. So this is what we have. Now looking out for the remaining least cost cell in the remaining entries. So this is gone. So as you will see, the first that dummy row is gone here. Now moving ahead, looking out for the least one, that's 9, and 100 and 150, 100 is the minimum. So this becomes 50. So this is also gone. Now particular column. Now the remaining cost cells, which one is the least one? That's 10. So 10, 160 and 50, obviously 50 is the minimum. So this becomes 110. So again, this particular row is gone, and we'll be looking out for the least cost cell in the remaining cost cells. Now in the remaining cost cells, the minimum is 13. So you could choose any 13 as you like. So this would be 140, and this becomes 60. This becomes 0. So as we could see, even this column is gone, and we'll be looking out for the least cost cell in the remaining 4 entries that we have, cells, sorry. So here 15 is the least cost cell, 110 and 350, 110 is the minimum, and I'll be getting here 240. So now the remaining cost cells that we have would be 22 and 19. So 22 and 19, 19 is the minimum cost cell. So 300 and 240, 240 is the minimum. This is gone. This becomes 60. So again, a cross check that it is 60. So every time when you are finding out, the last entry must have the same demand and supply. So as I told you that we have m plus n minus 1 is coming out to be 7. So we could easily cross check where we are having 7 allocations. Now the minimum cost that we'll be getting here would be equal to 140 into 13 plus 22 into 60 plus 19 into 240, 15 into 110, 50 into 10, 9 into 100, and lastly 0 into 90. So we are getting 7 allocations, and we could find out the minimum cost, and this would be the final solution. Again, when you will be comparing it, you could easily find out this would be less than what we have calculated with the northwest corner method. So this is the least cost method, where we are finding out the least cost from the matrix and then doing the same steps again and again. So in the next lecture, we'll be talking about the Vogel's approximation method, that's also called unit cost penalty method. And you can take have this as an example. This is an unbalanced transportation problem example. So you can try this, and you can find the answer, and we'll meet in the next lecture.